Alright, so this is going to be a video on an introduction to scripting in Godot. I'm going to assume that you already know how to program or script in general, and you just need a bit of guidance with Godot and how to access its scripts. So first of all, you might have noticed on different nodes I have this little scroll icon here. These are actually the scripts that are attached to those nodes, and right now I'm scrolled over so I can't see all of it. This is the actual code that extends this spatial node. And I can also access it by going down in the inspector to the very bottom of it where it says script load. If I just duck out of this and go into this, you'll see it also opens up load.gd. And this is what happens whenever, this is what code runs whenever I open a scene that has load.gd added to it. So let me make a new script on a random node here. I will not be keeping this, so it really doesn't matter what it is. So you can see this extends mesh instance, that's the node I clicked on. So this script now that I'm writing by default will only run on stuff that is a mesh instance or something that is a descendant of mesh instance. If you're familiar with object-oriented programming, this is, child and parent type behavior. Things in Godot can only have a single parent, so you can't extend multiple things at once. You will have to reenact some of the functionality yourself, or just use multiple nodes if you want multiple conflicting nodes to extend. So, as it says here, I can declare member variables here. This is where I would say that var a is equal to 2. Now I have an a that is in the class scope. So this will in the node scope. So this variable is going to be the same variable that's invoked anywhere within this script, as opposed to if I make var b is equal to 2, b is now only available within the scope of the function. So ready is a special function that I can overwrite or delete as I want, and it's called when the node enters the scene tree for the first time. So this is also an overridden function, and it's not overriding. Okay. Godot 3.5 does this differently from Godot 4. When you override a function in Godot 3, it adds it to what that function already does. So if I make an extension to panel main, and I make a new func ready, it's going to run the original panel main's ready, and then it's going to run my ready. So I cannot get rid of what my parent does, and I cannot modify what my parent does unless I'm able to do it entirely inside of the script. So, moving that aside, whenever I want to initialize something, I can do it in ready. And although any of my class variables I probably want to initialize in the raw like this, there's a lot of times when I want to initialize something in ready. Let's look at panels for an example. So if I go to the ready function, and by the way, this little screen here lets me jump between different different functions, sorry. Here I have that it's setting its own unhandled input to false, because player.gd will set that to true when it wants to. And I have different things here, like it's setting the viewport size whenever it is in the editor. It is doing this. It is prepping the background material. It is connecting a signal to itself. I'll go over signals later. And it's also setting the visibility notifier's distance depending on its own scale. These are all things that I want to do whenever the game loads and not whenever something happens. Let's go over engine.editor hint real quick. Panel is actually a tool script, which means that it runs not only in the game, but also in the editor. And for panels, that's actually how you're able to see what the answer is and what the clue is for panels. It works through it being a tool script. Let's return to the scripting for now. So ready is running this kind of stuff to initialize. This isn't something I can do all the time, and if I did this kind of thing where I'm saying the material next pass is equal to material, I would be adding extra unneeded file size to my map, which is a problem that I actually did with Dave panel, and it has been fixed in a branch. Oh well. So let's go back to our empty floor thing. So I have ready, and I also have another one, which is process. By the way, you might have realized that the hashtag here is the comment signal. So I can just delete ready and I'm not going to use them. Process and its relative physics process, also with delta. This runs once a frame, and oops, with a lowercase p, this runs once every physics frame. And in this case, I have delta. I preceded delta with an underscore here to show that I do not want to actually use delta in this function. So this is what this is warning me about here. It's saying the argument delta is never used in the function process. This is intended, prefix it with an underscore, delta. So delta will be the amount of time since the last frame was processed, and that won't always be stable, even for a physics process. A physics process will try to run once every 15 milliseconds, while a process frame will try to run as many frames as it can. And delta will be the distance between those frames. So physics process is generally going to be reliable unless you've really bogged down your physics processes. And then Godot is kind of trying to freak out to try and save that. Let's push that aside. These run once a frame. So if I want something that constantly modifies the game state, I would put them in process or physics process. Almost nothing in base Lingo uses process or physics process. So I'm just going to detach this script. And let's go to player. Player is actually something that uses process and physics process. No, I'm wrong. It just uses physics process. And this is where solving takes place. This is when you enter right-click or enter mode. And this is all logic related to that. This is logic related to paintings. And finally, we have logic related to movement. If I go down a little bit further, you'll see unhandled input. This is another special function that is called by Godot. So ready is called when a panel enters, ready is called when a node enters the scene tree, when the node is loaded for the first time. Process is loaded once per frame. Unhandled input is whenever input is shunted to this node, and Godot automatically does that. So this unhandled input in particular, it's only looking for input that has not yet been handled by another node. Sorry. No, that's correct. Sorry. And it'll get any of that. And of course, we want the player node to be able to move the mouse and rotate our view. So that's what it's doing. It's looking for a mouse motion input. So it's saying if our event is a mouse motion and player's in playable mode, and we aren't solving something, then move the camera relative to how the mouse moved. All right, so now that we've got this far, I should introduce you on how to find the Godot docs. So the first thing you can do is just go on anything that's a part of normal Godot, hold down Ctrl or Control, and click on it, and it'll bring up the Godot docs within your screen. This is not the most useful way to search for things, but on the other hand, if you're looking for a particular, if I'm looking for a particular function, I can click on the function, and it immediately brings me to that function and the page on which that function is relevant. On the other hand, I probably want to go to the actual Godot docs online a lot of the time, especially if I'm just exploring stuff. So you don't want this page, however. This page is up to date for Godot 4.2. And I like how it tells you right here. It also tells you down here. I don't want 4.2. We run on 3.5.2. So here's the page in 3.5.2, and it is actually different. This page in particular is one that a lot of you will find useful. It's how you add exported variables. So exported variables are these things right over here in the inspector: gravity, walk speed, run speed. So this, I can actually just change these on the node without changing them in the script. If I change them in the script, I will end up changing every single node that uses that same script. So I'll end up changing every single door or every single panel. And I don't want every panel's answer to be high. So I can make that into an exported variable instead. Now it kicks it up to the node, and the node is able to say, hey, I want my answer to be high. And if I look in here and I go up to the top, you'll see that I have different exports here. So the general idea of them is export is non-negotiable. I have to put that to make it exported. I can put a bracket and a data type to specify what my variable should be. This is semi-optional. I need to declare it as a var. There's other things I could declare it as, but let's declare it as a var. This is the name of it, so text is now what text will be called throughout this. And here, setGet is optional. SetGet says that I am now making my own setter or my own getter for this. So a set function, like set text here, whenever I try to change the text variable on the function, on the node, whenever I try to change this, it's going to call this function because I told it to up here. And the first thing it's going to do is set text is equal to value. Value is the change I tried to make, so I'm just saying, hey, whatever change I want to make, just pass it through. In this case, I'm not changing what I'm inputting to the panel. Like, I'm not making every 9 into an @ symbol or something like that. I'm just passing it straight through. But then, since you've set this, I'm using it as the trigger to do a bunch of other stuff, like trigger font size overrides and automatically resize the font on a panel, or and update the viewport so that this puts it into update once mode, so that I can actually see the changes on the panel when I'm not in the game. Sorry, when I'm not in the editor. So I told you before, this is... Oh, sorry. I can't remember if I said this in a previous attempt or this one. Panel is a tool script. That's actually how... I did not want to do that. Panel is a tool script. That's actually how it... tool scripts run in both the editor and in the game. And that's how how panel modifies the viewport so you can see what the text and answer is. So moving aside from that, we have this setter, which controls that behavior. That's one of the ways which you can control behavior, trigger behavior. So as you can see, as you can see, all of these have their type defined: export string and export vector 3. I could actually delete this, and Godot wouldn't complain, because I have also said equals string here. So when I say equals to something, I am actually setting a default value. So now, if I do this, it should complain at me. Typeless export needs a constant expression assigned to infer type. So here, I'm giving it a string, so it says, okay, I must be a string. But I can also do export string to achieve text. Now it's not going to complain because it knows what data type it should be. In this case, I don't want to modify it, so it just goes like this. It goes back to normal. So that's Godot docs. That's your brief introduction to exported variables. If you want to know more, the Godot docs are here, and they are fantastic. I have taught you some functions that are automatically called by Godot. Signals. Signals are an important part of Godot, and you might not have come across them before if you haven't done game programming. In a lot of other places, they're seen as a violation of object-oriented programming principles, so they're not really used. Let's open up the packed scene for our panel high here. Now you can see the full scene tree for an actual panel, and you can see what it looks like just floating in space. And if I go into the script for text edit, which is the thing that you actually put your text into, we can see it actually has its own complicated script, but it also declares that it has some signals: answer correct and answer unsolved. So if I go down to here, I can see that it emits the signal answer correct in the complete function. So whenever this panel text edit completes itself, it sends the signal answer correct. Who does it send it to? Anyone that's listening. So let's go to panel and let's go to ready. This runs when the panel is loaded. And we have here the line var connected is equal to this. The reason it's var connected is this is just a shorthand way of saying, you'll notice the underscore between it. I don't want this value to actually matter. Just discard the true false value of whether or not this function worked. So this function is looking at its own text edit. This panel is looking at its text edit. So if you port GUI panel text edit and connect the answer correct signal to myself to the function handle correct. So now the function handle correct, which is right below here conveniently, this runs whenever the panel is completed, in addition to all of this logic that happens whenever a panel is completed. Now, there's not always a lot of reason to break up functionality like that, but we want answer correct for a bunch of other purposes. If I go to panel biz and I go down to, say, my doors, you'll see that door here also has .connect answer connect to handle correct. So this is looking at all of the panels inside of it, and it's looking at all of the panels that have been set in the panels and in the panel group, and it's saying connect the answer correct and the answer unsolved signals to my own handle correct and handle unsolved symbols. So now our panel's text edit did not need to know that door existed at all. It does not need to know how many doors exist at all. It doesn't even need to know that door is a thing. It emits the signal, the door listens for the signal, and the door does something on that signal. So doors do this, countdown panels do this, paintings do this, There's a lot of things that can hook into panels without panels ever needing to care about them because they emitted a signal. So in general, in Godot programming, the general idea is that whenever you are referencing something that is a child of your node, you want to look down. You want to just call its functions directly. So here I am looking at label, which is set up here in my set text, and label is a child. So I'm just directly saying, hey label, add your font override. But then when I look at text edit, and text edit needs to change panel's behavior, this actually just says, hey, I have just answered correct. You need to do what you answer correct. So you signal upwards and you call downwards. You call your functions below you if you're calling something for your child, but you send signal upwards throughout the chain. This is only a standard, standard. It's not something that's mandatory. So you could send signals sideways or below, but in general, signal upward and call downwards. Because when you call downwards, you know what children you should have, unless you're setting them, during play and you don't necessarily know what children something might have, so you might want to make signals for it then. Or when you want to, and you signal upwards, so a child needs to talk to parents, or to an arbitrary other number of nodes, it emits a signal. So signal, it's very, very useful for this. Now, one last thing, I meant to cover this earlier and I kind of forgot. GD script is the language we are programming in. It is specially made for Godot. You can also, if you desire, program in C#. That is another option that Godot allows you. You should look at the C# pages on Godot docs to learn that. And it is somewhat Python-like, which is by which I mean it cares about white space. So here, this if statement right here is acting on all of the indented lines after it. If I indent this line twice, Godot is going to complain because it does not match the outer indentation level. So now it's of two different indents and it doesn't know what I want to happen. By contrast, if I just unindent these entirely, now it's reading this as being the only thing that's under the indentation. And this path is only described within the if. This path is only described in the scope of the if block, so it's no longer available to this. So now when I put it back, not this one. Now this is all executing this. If I want to make some nested ifs, I would just do it. Here we go. If, and then we have an else, and then an if inside of that, and we have a second layer of indentation. So whiles and ifs and all of your flow control is going to use white space. If you want to know more about GD script, I can only recommend the GD docs. If you want to know more about the logic behind scripting, you can look up any kind of programming tutorials along the web. If you want to know how to do something specifically in Godot, you're going to have to go over to the Godot docs and see, hey, is there anything already useful that I can use? And if not, how can I make it is a problem you're going to have to solve for your own. So this has been your brief introduction to scripting in Godot. There's a lot to cover, and this tutorial only assumed that you already knew something about scripting in Godot. So there you go.